take the topic Laplace Transform. The French mathematician B.Sc.VSem Laplace, he has worked on the various topics of Laplace transform, that is Laplace number, Laplace limits, Laplace derivatives, Laplace integrals. But I would like to take today the topic is Laplace transformation. First you have to know what is Laplace transformation. Now it is an integral transform that converts a function of a real variable to a complex variable. So first you have to know what is the definition of the Laplace transform. If y equal to f of t be an integrable function of t which is defined in the interval t greater than or equal to 1, then the Laplace transform of f of t is defined as L of f of t equal to integral 0 to infinity e raised to minus st f of t dt. So this is the definition of the basic definition of the Laplace transform. And generally the Laplace transform is denoted as L of the function, L of f of t, and the variable is in terms of t. So after the calculation or after integrating, the integral will be converted or the limits will be converted in the form of f of s, where s is the parameter. So with the help of the standard functions, we can derive the formulas of the Laplace transform: L of 1, L of t, L of sin at, L of cos at, L of sin at, L of e raised to t, L of e raised to minus at, so on. Which means the Laplace transform of all the algebraic functions, trigonometric functions, logarithmic, exponential, hyperbolic, as well as inverse hyperbolic functions can be calculated by using the standard definition of the Laplace transform. Now we can take a counter example for that. The first one is f of t equal to 1. Now with the help of the definition, what is the definition of Laplace transform? L of f of t equal to integral 0 to infinity e raised to minus st f of t dt. Now f of t is to be replaced by what? 1. So that the integral of e raised to minus st is as usual integration. What is the integral of e raised to minus st? E raised to minus st divided by minus, because your integration is with respect to t. Then after the integration, put the upper limit as well as lower limit. Now the upper limit is infinity. You know what is the value of e raised to minus infinity? E raised to minus infinity can be expressed in the form of 1 by e raised to infinity equal to 1 divided by e is a finite value, so that e raised to infinity becomes what? What is the value of 1 by infinity? 3. So that the upper limit value becomes 0 and lower limit e raised to 0. What is e raised to 0? 1. So the answer of all the Laplace transform L of 1 is equal to what? 1 by s. In the similar manner, we can find the Laplace transform of the function. Second one is e raised to 80. What is the Laplace transform of e raised to 80? 1 divided by s minus 1 divided by s minus a. So L of 1 is 1 by s, L of k is k by s, L of e raised to 80 is 1 divided by s minus a, L of e raised to minus 80 is 1 divided by s plus a, and L of sin 80 is a divided by s square L of cos at is s divided by s square plus a square, and L of sin h at is a divided by s square minus a square, and L of cos h at is s divided by s square minus a square, and L of t raised to n is n factorial divided by s raised to n plus half. So these are the standard formulas of the functions by using the Laplace transform. Now coming to the linearity property. The linearity property can be taken as the sum or difference of the two functions or more than two functions. Now the first one is L of f of t plus g of t. Here f of t and g of t are the two functions. How to operate the Laplace transform when the functions are in combined form, which means sum of the two terms. So L of f of t plus g of t. Once again, we will find out the Laplace transform by using the standard definition. What is the standard definition? L of f of t equal to integral 0 to infinity e raised to minus st f of t dt. Now, with respect to the linearity property, f of t is to be replaced by what? F of t plus g of t. Right? F of t plus g of t. Separate the two integrals. Separate the two integrals so that it is converted in the form of L of f of t plus L of g of t. Which means that, that means we have observed that in case of sum or difference of two or more than two terms, then to evaluate the Laplace transform, you have to operate separately. In general, L of f of t plus g of t plus phi of t, so all equal to L of f of t plus L of g of t plus L of phi of t, so on. So that is the formula we use in the case of linearity property. And second one is L of k into f of t. What is L of k into f of t? K into L of f of t. Which means if by operating the Laplace transform, the constant can be taken outside, and that is k can be taken outside when evaluate L of f of t. So that is the second linearity property, and in general we will take L of a into f of t plus or minus b into g of t equal to a into L of f of t plus or minus b into L of g of t. Now the standard function, if f of t equal to what? T raised to n. The different function, t having some power, the power is denoted as what? N. Now by the definition, in place of f of t you have to replace what? T raised to n. Correct? Then the integration can be done by using substitution method. You know, varieties of methods are there in integration. One of the method is integration by substitution. The substitution is minus st equal to, or you can take st equal to what? X. Therefore, what is t? X by s. S into differentiate with respect to dt by ds equal to, what is dt by dx? 1 by s. So s dt equal to dx or dt equal to dx by s. If you have converted the function t in terms of s, then take the limit. If t equal to 0, then x is also 0. If t is 0, 0 into s, that is x is also equal to 0. In place of t, replace t equal to what? Infinity. Then x becomes what? X is also infinity. by x. After that, e raised to minus x, it becomes x raised to n. But here, s raised to n into 1 by s becomes what? S raised to n plus 1. Take 1 divided by s raised to n plus 1 constant outside the integral, because integration is with respect to the variable x or with respect to dx. So that 0 to infinity e raised to minus x into x raised to n. Now convert this e raised to minus x into x raised to n plus 1 minus 1. Adding and subtracting 1. 1 divided by x raised to n plus 1. But we know, according to the definition of the gamma function, beta function, gamma functions are there. So according to the definition of gamma function, the value of this integral is equal to gamma of n plus 1. So that is equal to n factorial divided by s raised to n plus 1. Once again, gamma of n plus 1 is n factorial. Therefore, Laplace transform of t raised to n is equal to how much? N factorial divided by s raised to n plus 1. For example, what is the value of